Okay, so the next class of chemical reactions we want to discuss we call synthesis reactions. So as you could probably guess, synthesis reactions synthesize something. So they take two things and stick them together to make a new thing. So typically for synthesis reactions, we recognize these because they have multiple reactants and only one product. Okay, so if you want to make a note of that, you can. Synthesis reactions typically have multiple reactants and only one product. So there are 6 major types of synthesis reactions that we have to look at. We'll go through those and they kind of help us predict what type of product will be produced. But the good news is the first type is the by far most common type of synthesis reaction. It's also the easiest. So let's go ahead and dive into that. So the first type of synthesis reaction that we want to look at we call a direct union. Okay. So a direct union, you literally just stick two atoms together. Okay, so this is by far the most common type and by far the most simple type of chemical synthesis reaction we have here. So let's just look at potassium plus bromine. Okay, so remember, if I have potassium plus bromine, bromine's special. Okay, and I'll go ahead and tell you here. Typically for synthesis reactions, we don't worry so much about the phase symbols unless the word problem explicitly says solid potassium plus liquid bromine produce something solid or liquid, for example. So here we won't worry about it. So the problem might just say potassium reacts with bromine. What's our product? Okay. So to solve these problems, you drop off the subscripts and just stick the atoms together. Okay. Br. But it is very important to go back and check your charges. Okay. Because this is an ionic compound, a metal plus a non-metal. So I have to make sure the net charge is 0. So I have +1, -1, that equals 0, so that product is correct there. But I'm not done. I have to go back and balance it. Put a 2 there, put a 2 there. Now I'm good to go. So let's look at another one. Let's look at magnesium plus iodine. So Mg plus I2. Again, I just go ahead and I stick them together. Okay, I need to go back and look at my charges. +2, -1. Those don't cancel, so I cross my charges and get MgI2. So here we see it's already balanced, so we're good to go. Let's look at one more. Let's look at aluminum plus, what did you say, fluorine? F2. Okay, so it's very important we don't forget the diatomic atoms here, because typically these diatomic elements are the ones that participate in direct union synthesis problems. Okay, so I just write the elements together, AlF, check the charges, Al's +3, fluorine's -1, so I cross them, I get AlF3, then I go back and balance with coefficients. Okay, so I have 2 over here and 3 over here, okay, so one's positive, or excuse me, one's even, one's odd, so I need to make the odd one even so I can balance it out. So now I have 6 fluorines, so I need to put a 3 here, now I have 2 aluminums, now I'm all balanced. So I know I said earlier we never could use subscripts to balance reactions. So let me make sure we're clear on what I just did here. I use this subscript to balance the charges, like we learned in the past writing the formulas. I use the coefficients to balance the reaction. So there's a big difference there. Be sure you only add subscripts if you're balancing the charges or dealing with a diatomic element here. Okay? So that's fairly simple. Just stick them together. The only tricky part is to make sure you go back and double check your charges, make sure you write the correct product. Okay, so the second type of synthesis reaction we have is a metal oxide. Okay, so a metal oxide is a metal bonded to an oxygen, so like magnesium oxide, potassium oxide, something of that nature. Actually, sorry, I got ahead of myself. The second one in your notes, I believe, is a non-metal oxide. Plus water produces an acid. Okay. So go ahead and put a big star beside number 2. For our number 2, we have to use something called the gas ion chart. And before we discuss that, let's make sure we know what a non-metal oxide is. So a non-metal oxide is something like nitrogen and oxygen bonded together, phosphorus and oxygen bonded together, something of that nature. And we know an acid always begins with an H here. So let's look at a problem then we'll see how to use the gas ion chart. So it's going to learn by doing here. So I might have sulfur dioxide gas plus H2O liquid. Okay. So I see this. I can't just stick them together. Okay, it's not a direct union. It's not two simple atoms. It is a nonmetal oxide plus water. Okay, so when you have a nonmetal oxide, you have to refer to the gas ion chart to see what ion this nonmetal forms when it dissolves in water. Okay, so go further down in the notes. You'll see the little gas ion chart. This is something you'll always have access to. You won't be required to memorize this. That's a little excessive. So you'll have access to it on all assignments in the test. So find SO2 in the gas column and go to the ion column and see what ion it produces. So you see it produces sulfite. Okay, so SO3 with a -2 charge. So I can write down here sulfite. Okay. So now I need to make an acid out of sulfite. So if I have SO3, and I can write -2 above it, I know acids start with H. Okay. Hydrogen has a +1 charge. Does +1 and -2 cancel? No, it doesn't. So I cross my charges, and I have H2SO3. So hopefully you remember we can name that as sulfurous acid. So if we dissolved the gas in the water, okay, it went from a gas molecule to an aqueous ion. So if it's aqueous, if it's dissolved in water, I can use the symbol AQ here. Then I can go back and balance it, but it's already balanced, so I'm good here. So let's look at another one. I could have N2O5 gas plus H2O liquid. I need to know what the product of this reaction is going to be. Okay, so I need to recognize, oh, it's a nonmetal oxide plus water. When it's a nonmetal oxide plus water, I have to consult my gas ion chart. So if I go to the gas ion chart, you find in the gas column N2O5, you see it corresponds to the polyatomic ion nitrate, NO3. So down here I can write nitrate. The product side I can write NO3. I know NO3 has a -1 charge. I know acids start with a hydrogen. Hydrogen has a +1 charge, so I know I'm good, HNO3. I really should write it closer together. I should have left that space there. Okay. So I know it's dissolved in water, so I have AQ. Okay. So now I can go back and double check this one. I need to balance it because this one is not balanced. So I'll leave this one for you to do on your own. So go ahead and pause it and try and get this one balanced. Hopefully see it's pretty simple. We put a 2 right there in front of HNO3 and it's balanced. So remember HNO3 we could call nitric acid. Okay. So again, this the second class of synthesis reactions, they aren't necessarily difficult. You just have to be able to recognize what's going on. If you see a nonmetal oxide plus water, you have to recognize it's going to produce an acid, and I have to go to the gas ion chart to see what acid it's going to be. Okay. So now, where I got ahead of myself earlier, let's look at number 3. It was the metal oxide plus water. Okay. So the metal oxide plus water, your notes say it produces a base. Okay, so what bases look like is they are a metal with a hydroxide. Okay, and then we will of course balance the charges. So if you see a metal oxide, so something like magnesium oxide, potassium oxide, aluminum oxide plus water, we know we're going to produce a base. Okay, so a metal plus a hydroxide polyatomic there. So let's look at one. Let's just look at K2O plus H2O. Okay. I could tell you this was solid metal oxide, then we would use phase symbols, but if the problem doesn't specify, then we can just leave them off. So let's just say I did say solid, and H2O is going to be a liquid. I'm going to produce a base, so a metal. The only metal I have is potassium plus hydroxide. I need to go back and check my charges. +1, -1, they cancel, so I'm in good shape here. So potassium hydroxide would be aqueous here because it's dissolved in water. I would need to go back and balance this equation. So I need to put a 2 right here. Now I have 2 potassiums, 2 potassiums, 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. I'm in good shape here. So now let's look at, let's say I have magnesium oxide. and we'll just leave the phase symbols off here so the problem did not specify, plus H2O yields. Okay, so I recognize it as a metal oxide plus water, so I need to make a base. So I start off with my metal, Mg, then I need a hydroxide. Okay, and you go back and check my charges, plus 2, minus 1, those do not cancel. So I need to cross my charges to MgOH2. So I have to put the hydroxide in parentheses because it's a polyatomic ion, so be careful there. So go back and double check, see if it's balanced. I have 1 magnesium, 2 hydrogens, 2 oxygens, so I'm in good shape there. Okay. So now let's move on and look at the fourth class. So we're going to combine the fourth and fifth class. So the fourth class is kind of a generic example of a non-metal oxide plus a metal oxide produces a salt. So a salt, in chemistry, we use the term to denote an ionic compound. Okay, so we're going to produce some positive ion and some negative ion, and they'll produce an ionic compound here. But we're going to look at the specific example of the fifth class. Okay, so the fifth type of reaction listed is just a subset of the fourth reaction. We're only going to discuss that. So we'll skip down to synthesis reaction type 5. So a metal oxide, we can say metal oxide plus CO2, carbon dioxide, produces a metal carbonate. Okay, so a metal plus carbonate is CO3 there. So let's look at an example of this. If I have K2O, first I have to recognize that this is a metal oxide. Okay, then I have CO2. Okay, if I gave you phase symbols, we could worry about this, but for now we'll just leave the phase symbols off here. So if you have to recognize, you do have to recognize metal oxide plus CO2. Once you recognize that pattern, you remember, oh, it's just a metal carbonate. So KCO3, check my charges, plus 1, minus 2. Those don't cancel. So I cross my charges, get K2CO3. Now I go back and balance the reaction, but in this case it's already balanced, so we're in good shape to go. So let's try one more of these. Let's try MgO plus CO2. So again, you have to recognize a metal oxide plus carbon dioxide, so we're going to have a metal carbonate. So MgCO3. Double check my charges, plus 2, minus 2, they cancel out, so I'm in good shape there. Go back and make sure it's balanced. It is, so we're in good shape. So let's go ahead and look at one more class. Class number 6, or group number 6. We'll say metal chlorides. So NaCl, MgCl2, a metal plus a chlorine, plus oxygen, produce metal chlorates. Remember, chlorate, the polyatomic is ClO3. Okay, so hopefully you remember the charge of chlorate. So if you don't, go back and double check your polyatomic list and refresh yourself. You should recall it has a -1 charge. So let's look at a few of these. So NaCl plus O2. Again, we can include the phase symbols if I gave them to you. So we could say solid sodium chloride plus oxygen gas. So if we react a solid with a gas here, we'll most likely produce a solid product. So my product is going to be the metal chlorate. So metal is Na, chlorate is ClO3. Do my charges cancel? Plus 1 sodium, minus 1 chlorate. I'm in good shape, I'm good to go there. So that's a solid. Go back and double check, is it balanced? Okay, I have 3 oxygens here, I have 2 oxygens here. That's a little bit of an issue. I can put a 2 out in front here. Okay, so now I have 2 sodiums, 2 chlorines, 6 oxygens. I need to put a 3 there, I need to put a 2 there. Let's go back and see if it's balanced now. 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 6 oxygens, 6 oxygens. I'm in good shape now. Let's go ahead and try one more. Let's try MgCl2 solid plus O2 gas. And that would tell you to predict the products here. Okay, so hopefully you recognize it's a metal chloride plus oxygen gas. So I'm going to get a metal, Mg is my metal, chlorate, ClO3. I go back and I double check my charges, plus 2, minus 1. Do they cancel? No, they don't. So I have to cross them. MgClO3 2, and that would be a solid there. So now I have to see, is this balanced? So I have 2 magnesiums, 1 magnesium, 1 magnesium. I have 2 chlorines, I have 2 chlorines, I have 6 oxygens. So I put a 3 right there to make sure I have 6 oxygens. Now we're all balanced. Okay. So those are the major synthesis reactions that we'll look at. So hopefully you found that none of these by themselves were super difficult. Okay, they're all fairly simple. The difficult part is recognizing which one of these the reaction we're discussing falls into. Okay, so the most common and most simple is the direct union. You stick them together. But if you have something more complicated down here, don't just try to stick them together. Okay. Think about, what do I have? Do I have a metal oxide? Do I have a non-metal oxide? What is it reacting with? Water, CO2, O2, whatever it might be. Think about your rule. Okay, these are rules you have to commit to memory. You have to be able to predict these products. Okay, recognize the type of reaction, which is probably the most difficult part, then predict the product, then always go back and balance. The one thing you won't need to commit to memory is the gas ion chart, obviously. Just remember when you have to use it, but don't worry about memorizing that. That'll always be a resource for you in your notes. So you might even want to go as far as to make flashcards for the different types of synthesis reactions we have, what they look like, and what the product that is produced from them looks like as well.